Hello everyone, welcome to my YouTube channel Data Partnership. So today topic is Mumbai flood mapping using Google Earth Engine, right? So how to map? You can use your own study area, means in Gujarat, someplace in Gujarat, Assam or somewhere, but I did it for Mumbai because my target was to show the urban flooding. So in this video, I will demonstrate how to map the latest flood inundation in Mumbai using Google Earth Engine. So for this analysis, I'm using Sentinel-1 SAR data, SAR synthetic aperture radar data. So the advantage is by using Sentinel-1 is that it is radar satellite. So unlike optical satellite imagery, it can acquire data even when there is a cloud cover. This is the everybody knows about it. So this is particularly useful during flood events because floods are often associated with cloudy and rainy conditions. So first, this is our study area. So we have defined this. So I can tell you. So this is you can say this is the study area. You can draw your own area also. You can take smaller area, no issue. So I have taken this geometry of Mumbai. So you can just take see my previous video how I delineated the AOI, area of interest. So you can use that also. So second is that selecting the sentinel data, right? This is the important thing. So first, uh, this is it should be for my study area. So basically, what we are using that we are using the VH polarization, right? This VH polarization means and the mode is the interferometric wide IW, right? So you can read it about it. So I'm not going to tell you about that. So but basically what we are using IW and VH. So VH basically useful for identifying changes associated with the water and vegetation. That's why we use the VH. So first the important thing then is the how to. So these are the code how for to selecting the satellite image. So then how to find the latest available image. So one important part of this script is the how we specify the latest satellite image. So instead of I sort the Sentinel-1 image according to their acquisition time from newest to the older, right? So the first emoji is therefore the latest available Sentinel-1 acquisition over my study area. So for this Mumbai analysis, the latest available acquisition returned by the Google Earth Engine is the 8 July, um, 8 July, 8 July 2026. So this is the code for that. So this is important because satellite image data is not necessarily available in Google Earth Engine for immediately after acquisition. Sometime it takes some time, right? So rather than assuming that an image exists on a particular date, the script automatically find the latest available image, because otherwise if you manually find, then it would take a lot of time. So this is the important thing actually, to do how to what is the latest image you can find. So then after that, find pre flood image, right? So now we need something to compare the latest image against. The latest image alone cannot tell us whether an area is flooded or not. So therefore, I selected Sentinel-1 from before the flood event, right? So I searched the imagery approximately 10 to 40 days before the latest acquisition. So that's why. So this is the script for that. This is you can use. So I also make sure that the pre-flood image has more orbit direction at the latest image. So because this is important because Comparing image acquired from different viewing geometries can introduce unwanted changes, right? So this is the general scenarios where we have to basically this is required for the flood interpretation. The interpretation is important actually, so you need to hit and trial. So this is the code for pre-flood images. So what? So this is how we have before. These are the code. You have to write it, right? So then we have to clip with our study area, right? This is a simple thing. So so these are the before and after uh, flood, right? After image basically. So now display two Sentinel image. First image according to the pre-flood condition, and after is the after the flood means condition, which is the 8 July 2026. So at this stage, we are not yet looking at a flood map. We are simply looking at the radar backscatter before and after event, right? So this is what we are just looking how it looks like before, how it was earlier, how after the flood. So these are the. So then what we do the speckle reduction. So Sentinel-1 radar actually what happen is they have different means noise called speckle. To reduce this noise, I apply simple the special smoothing filter, right? So I did that. So this is the code for that, right? You can check about that. You can read it about. Then we have to flood change, flood change detection. So now to calculate the ratio between the latest image and pre-flood image. So this is the ratio you have to see here. The basic idea is open water has very low radar backscatter because much of the radar signal is reflected away from the satellite. So when an area becomes flooded, the radar backscatter can decrease significantly. So this is the main thing. This is the technical thing here, right? So we look for pixel where post-event radar signal is substantially lower than the pre-event signal, right? So in this workflow, I'm using threshold is 0.75, right? So you can use that further also, but that will come in the next video because this is important actually. So here right now we are using 0.75. So pixel below this threshold are considered potential flood pixel, right? So removing the permanent, however this is important thing. So now remove permanent water. What the meaning of that? However, there is an important problem. Mumbai already contains permanent water bodies such as rivers, lakes, pond and sea, right? So we don't want to classify these as newly flooded area because sometimes because it's already there. So therefore I use the JRC Global Surface Water data, right? This data set provide the historical occurrence of water. True. I use areas with more than 90% water occurrence as permanent water and remove them from the flood resource. Otherwise, it will duplicate. Then it will show lake area also as a flood. So I use so therefore final flood layer represents areas that are detected as newly inundated rather than simply being permanent water. So then after that we just remove the small noisy patches. The initial flood classification may contain isolated pixels, very small patches. Therefore are often caused radar. These are the noise actually, right? So then we have to do the flood area calculations. You can see here the flood area image, flood multiply with the pixel area. Similarly, you can see here these are just the calculation. Then we have population affected. So we are using the you can say means why how to we want to understand the potential human exposure. This is the important thing. Why we are doing this, right? So then I use the world population dataset WorldPop. So WorldPop provides high graded population estimates. We have used this, right? So I overlay the flood mask on the population layer. The population values falling inside the detected flood area and then some. So we can see this is the popular exposure estimate. We'll see about this. Of course, sometimes it not gives the correct population, because we have to do a lot of things. This is just I'm giving you the framework how we have to do. Of course, in next video we will see how exactly how much population is affected, or whether is there. And this is the satellite base, roughly. Yeah, because we need to do a lot of field investigations, also modeling and all. Then only we can say. How much people affected to that. So, so we can also estimate the agriculture area affected by flooding, right? So we have used ESA World Cover Land Cover dataset. So, this is in World Cover class 40 represent cropland. So that is the things. Yeah, this is this one, right? So we have mentioned here. You can see, because I have used this data set, right? So how to add that map into that. So we have the what will give the estimate of flooded cropland. So this is so now after that we have to the what will happen is final result will come once you run this. So you will have a lot of images. So what will happen in the first is the estimated flood area in square kilometer. So you can see um, total Sentinel image 307, latest this one date, and you can see number of possible pre-flood six. These are the pre-flood scenario. Date is this one. What I have talked to you about the estimated flooded area is this one, 4.5 square kilometer. Population affected is 0, and the cropland is this much square kilometer. So so these things happen actually, and you can see your thing here. We have this. This is the flood raster. You can say. You can this. Okay, it will load, right. This one is the flood raster. Yeah, it is coming, right. So this is the flood raster. You can see here. We'll see some this type of one, right. So this one is the just so before this is coming, I this there is some limitation also, right? The because Mumbai is highly urbanized area, so building roads, radars, so shadows and other urban feature can create changes in this Sentinel-1 back scattered, right? So something it looks similar to the flooding. So therefore, this should be considered a satellite-derived flood inundation estimate. It is not, So for more advanced analysis, we can improve the methodology using automatic also thresholding. We will use that in next video. DM-based slope masking for better speckle filtering and urban area masking. So this is satellite-derived. So you can see here this is our flood raster. You can see, so these are the flooded, this one, and these are the flood croplands. You can see this one somewhere we can see here, right? I will just go above, just tap on it. So this is the cropland, and this is the flood area. Yeah, you can see here. Yeah, right. These are the flood area. These are the SAR change ratio, and you can see first before and after. You can see here mm, this one, right. Yeah, you can see the changes, you can see, right. So you can zoom here, so better to understand this. This is July, 8th July, yeah, you can see, right. So this is just a a task to understand the flood extent, or how it looks like, right, by using satellite data. Means I have used Sentinel-1 SAR data. So I will give you more detailed video about the flooding, So please stay with me, and in the next video, I will give you more advanced analysis. So this is, I hope this will help to you. But whatever I am learning, so I am giving you for to you also, that you also learn, and you can get some idea from my video. So if you get anything means from my video, so that is very you know it's good for me, right? So that it gives me happiness. Okay, that at least this video helped someone, you know, to start the things, and you can do better also, right? This is what I learned. So thank you. So please subscribe my channel, share, and comment. You know, thank you.